Yeah, we did a join, right? So in join, did you try full outer join and see? Okay, I'm just designing a job for join. My PC did not work yesterday, right? So let me just design it. So PPT, load the table structure. I just imported it. This is the EMP. Rename link underscore EMP. The join job only I'm designing. Okay? PPT. So here, just we need to give a key column in join stage and pass the output columns and then give a output file. So insert parameter ds outpath slash join.ds. Okay, so that's it. So you have given employee, department, type of join we are taking inner join. Okay, we need to save this job. mpdept join job. Okay, it's fine. When you do inner join, that's okay. When you change the join, as I said, key column, you need to remap the key columns, because if you are taking a column from one table, key column, that will be taken from the primary table. If you change it to right outer join, department table come from department table, because right is a primary in right outer join. The left outer join, left table is a primary. Inner join also left table is a primary. Okay? But when you do full outer join, it will return both the primary keys. Okay, so I will show you the example. So inner join, left outer join, or right outer join will show only one department number from one side only. But when we do full outer join, it shows from two sides. Okay, let's see the difference. So this is a generic. We have only 8 columns, 8 columns and 14 rows. Okay? There is no difference. But when you go to full outer join, you guys can hear me, right? I didn't hear anyone speaking. Right, Sweta, can you hear me?
Yeah, I can hear.
Okay, okay, sure. So when you do full outer join, so if you go to output and you see left record and right record, department number is showing from left and right. So what is our left table? If you go to join and link ordering, stage and link ordering, EMP is left, department is right table. That's what the link label is showing. Link ordering, it will show what is the table, what is the left and right. Okay. Yeah, recording is there. Okay, so employee and department. Okay, so when you go to output, it is showing department number from main table. It won't show anything. Left table, right table, it is showing the right track. Okay, if you want, you can simply remove this and remap it. So you can clearly see left is nothing but employee, right is nothing but department table, department number. So if you run and see the data, then you understand. You can view the data and see the differences. So full outer join will return all the records from both the table, whether there is a match or not. It doesn't care. But it will show nulls for the unmatched departments. Okay. So right click and view data. It is a data set. Okay. So now you see left record department and right record are, if there is a match, then left and right you will see department numbers. Nothing but primary keys will be shown. Join key will be shown from the both the tables. Somebody is not unmute. Sarita, can you go unmute, Sarita? Yeah. So if you see here, primary key is there in the both the tables, left and right. But the 40 is not there in the employee table. See, all the columns from employee table is a null. But right side table, it is having data. That's how you can identify which one is which. So clearly it is showing nulls. That means employee table doesn't have any record for department number 40. Okay. So, but department details are there, but there is no department, there is no employee in that department. Okay. So how do I capture unmatched records? So if I do where left record underscore EPT number is null, that is a unmatched records in a left table. If I do right department number is null, that is nothing but unmatched record from department table. So here you can use a filter stage to capture the rejects. Okay. If you see the filter stage, in the filter stage, let's say I want to capture unmatched data from this table. In the where class, you need to go to columns. If it is a left table, then you have to take this key. So right click and copy the key. Stage is null. Okay, we have to put null. You cannot do equal to null. Okay, null is not equal to anything, or you cannot add, you cannot minus, you cannot cross anything with the null. Null is a undefined value. You have to do it like this only. Is null. Okay, left department is null. Yeah, go to output and map the columns and save the data to output. Browse insert parameters, out path, slash, join, so expected record will be only one because it's a rejected data. So if you want if you want unmatched records from department table, you just take the right record, right track. Okay, that's what the significance of left and right tracks. It's very important. Sometimes they may ask, okay, how do you capture the unmatched record from both the tables in a single job? Okay, this is the only way to capture the unmatched record from both the tables by using join stage. Okay, so here there would be only one row because there is only one record unmatching. See, one record is there. So if you right click and view the data, it will have only one record, which is a department number 40. Doesn't have any values for employee. Okay. To understand these concepts, how to capture the rejected record from by using filter stage. You can have another link also and capture unmatched records from right track, but there are no records here, so you don't need to do that. Or use a reject link, it's up to you. Okay. So there is a one prerequisite while you are doing a join. Okay, this job is running on two nodes. Okay, so if you go to configuration file, we have a tools configuration file. We have only one configuration file. Default configuration file is running on two nodes. Okay, that means our data 14 records are distributing across two systems, two CPUs. So 7 records handled by one CPU, another 7 records are handled by another CPU, another node. We call it a node. Don't call CPU here in data stage. We call it as nodes or any other tools also. So we don't know which record is handled by which node. Okay. So for the join, I will explicitly mention just send these type of records to this node and this type of records to this node. See what is happening now? Extraction, join, transformation, and then output. Extraction, this is extraction part, transformation, and then loading. So extraction, transformation, and loading is happening parallelly. That's why we are seeing speed. Okay, in real time, you will see 10,000 rows, 20,000, 40,000, 1 lakh rows per second. So here you see 15 rows in total, 2 rows per second is a speed. But when you go to real time, you will see 20,000, 30,000, 1 lakh records per second. First one is a total rows. Second one is rows per second. Here 1 row per second. Here 0 rows per second means 4 rows were read instantly. So 4 rows per second is a speed. 0 means here. Okay. So here extraction, transformation, and so generally what happens in olden days. So when you have a 14 records, so for first record extraction, transformation, and loading should happen, used to happen sequentially. So second record would be waiting for first record to complete extraction, transformation, and loading. Third record will wait for second record to complete. Fourth record will wait for another record to complete. Okay. So this was becoming a problem because in olden days it might have worked because we had only few customers per bank. Let's assume if you take any telecom or banking sector. So, but gradually we are getting more and more customers. So that system is just slowing down. Okay. So IBM at data stage had come up with the solution called parallelism concept. Okay. Means so second record don't wait for first record to complete. Okay. So batch of records will be sent to the sent for extraction, transformation, and loading. Second batch will not wait for the first batch. So parallelly, everything will go in parallel. Okay. So parallelly, they will go. Okay. Records, extraction, transformation, and loading will happen parallelly for the bunch and bunch of records instead of a single record. So when you compare against a sequential process and parallel process, parallel obviously parallel job will work faster than sequential. So server jobs, we used to have a file. If you go to file new jobs, here you see server jobs. They used to run on a sequential manner. Okay, so it's a very old jobs around 12 years ago. Okay, so but parallel jobs, it's a parallelism technique. They applied it on the back end. We don't know how it works, but it works. Okay, so that's architecture design, right? So it's a coding on the back end. You cannot visually see that, but that's how we are achieving speed here. Okay, good speed because of parallelism technique. So simple concept. So let's take a small pipe. Okay, remember this pipes concept. It's very important. Okay, this is how data is flowing. Take the very thin pipe. Okay, and put a balls in there. Okay, so what will happen? So ball is just fitting through the pipe and pour some water in that pipe. So what will happen? So these balls will go one by one. Sequentially, balls will be going flowing through the pipe. Okay, so there is no escape. Second record should wait for first record to go out. Okay, now you take a thick pipe. Okay, which is having a radius of maybe very big radius. Okay, so maybe 100 centimeters radius of big pipe. Now you leave a small balls, which is a 10 radius balls. Just leave the balls inside that pipe. So what will happen? So second ball will not wait for first ball because there is enough space to move, right? Okay. So when you put a 10 balls in a pipe, what will happen? You don't know which one will go first. Okay, to the end, right? When you put a water in there, so everything will go in parallel. So same technique IBM had applied for the data stage for parallel processing. Okay, does it make any sense?
When you like shown us the tools configuration, it was showing two nodes, right? So that is parallelism, showing two nodes.
That is a pipeline parallelism. Yeah, 7 records are going through one node and another 7 records are going through another node.
Okay.
And yeah, so that's a pipeline parallelism. First, understand the parallelism. After that, parallelism has a two types of parallelism in IBM data stage.
Okay.
First one is a pipeline parallelism. Second one is a partitioning parallelism. So let's
Okay.
come to pipeline parallelism. So now you are sending bunch of balls through pipe. That's fine. Instead of sending a bunch of balls through one pipe, just I will take a two pipes. Okay, put a bunch of balls through two pipes. Now you will achieve best speed, right?
Yeah.
That is
Yeah.
nothing but a two nodes here. So extracted records will be sent to through two nodes. So data will be splitted evenly, and bunch of records parallelism will be applied on top of that.
Okay.
Okay, that's
Yeah.
called pipeline parallelism. Pipe is
Mm-hmm.
nothing but a pipe is nothing but here that's a node. That's it. Okay,
Yeah.
data is going
We are
through
not
pipe.
controlling it, right? We are not controlling it. It's directly data
No, you
stage.
can. Pipeline parallelism, you can't control anything. All you can
Okay.
control is you can add more nodes to that. That's it. You
Okay.
can't control. Just by adding another node, you can achieve best speed. That's it. You cannot even tell which record is going first and last. Okay.
Okay. Okay.
Okay. So that is one technique. But there is another technique called partitioning parallelism. Okay. So partitioning parallelism, you can control it now. Okay. So okay. So let's assume there are four colors of balls, white, red, green and blue. Okay, I want to set all white balls to node 1, red balls to node 2, green balls to node 1. Oh, we have only two nodes, two pipes. So and I have a four colors. Obviously I will have to split 2 and 2. Okay, if I have a 5 colors, I need to split 3 and 2 when you have a two pipes. So as I said, so there are five, let's assume four colors evenly first. Understand this small concept. So I have a four colors. Okay. So now I need to distribute across the two pipes. All white balls in pipe 1, all red balls in pipe 2. I mean to say first color into first pipe, second color into second pipe, third color will start again into first pipe, and fourth color into second pipe. So now I am telling data stage, okay, instead of you choosing a records, I will give you the key column. Based on the key column, you choose the records. Okay. So here, how many departments we are having? So here we have a three departments. So I'm going to tell data stage. Okay, use this key. Okay. So by department number, take bunch of one department into one node, another bunch of another department into another node, another department into another node. So I'm asking data stage, take group of records into one node by groups and groups of data. Okay, so that is nothing but a pipeline partitioning parallelism. So here, how do you do that? So if you go to input, while data stage while join is reading a data, so I'm telling input. While reading means it's an input. Apply the partition technique. So you see here partitioning tab, input partitioning. What partition you want to apply? Hash partition. Hash partition, okay. Hash is nothing but a group of records. We are telling to the data stage nodes, take the group of records. That's what the hash meaning. So based on which key column? So it's a key column. So inside the partitioning techniques, we have a two types of partitioning techniques. One is a key based, another one is non-key based. So key based hash is a key based partition. Okay. I need to give a key, which is a department number. Okay, anyhow, you are distributing the data across nodes based on this key column. This is for only employee data, I'm telling. Okay, So you have to do it separately for both data. So based on department number, data will be distributed into nodes. Okay. So anyhow you are doing it. So while you are distributing data into the nodes, just sort your data. If you tick on perform sort, your data will be sorted. How it will be sorted? Ascending order. If you want to change it, you can change it to descending also. Right click and change the order, but don't change it. Just take the default unless you know what you are doing. Okay. Here you see unique. Unique means it will remove the duplicates before it is sending to the join. Okay, so here they are not real duplicates. Okay, I don't want to remove the duplicates. If you select unique, it will remove the duplicates. Like while you are doing a sort, it will allow the option to remove the duplicate, like in the other sort stage. Stable sort means it will not sort the data, resort the data again. It will keep the previous sort if your data is already sorted. Okay. So here I'm just telling apply the hash partition. Hash partition means all 10s will go to first node, 20s will go to second node, and 30s will go to again first node. If there are 40s, then it will go to second node. That's how employee data will be distributed. So why we are using this partitioning technique means, so if you combine pipeline and partitioning techniques together, you will achieve best speed. And we have a control of we have the control of data to send to which node and all. Okay. So join works faster on hash partition, and this is a prerequisite of join. When you are handling with huge amount of data, if you are just dealing with small amount of data, you don't need to apply it. By default, it will take it, but explicitly mention it when you are doing for the millions and millions of data. Similarly, I need to apply for department table also. Apply hash partition, perform sort, and department number. Okay. So now you see there are symbols here. So sort and data is redistributing across the nodes. This red color symbols means cross symbols. This is a sort symbol. This is called link sorting. You can do link sorting in any stage. Go to stage, input, partitioning, and all. Okay, you can do anywhere, but don't do it anywhere. Just you do it wherever I say. Okay, so that's what the use of join. And now if I run my job, it should work faster. So without when you are dealing with millions of records, you will see the speed difference. But here you cannot see any difference. We have only 14 and 4 records. So if you get a speed without partitioning technique, you may get maybe 20,000. If you apply partition, you may get 25 or 30,000. Okay. So what happened? Duplicate records are generating. Why duplicate? What did I apply? Hash partition. Okay, based on department number. Partition enter. See, I applied the wrong partition, so it is started generating duplicate. I will talk about entire partitioning. What is that? Okay. Make sure you apply hash partition only.
Yeah, for to get the accurate records, you need to apply only the hash partition.
No, it's a depends on stage. Which stage you are using, you have to choose. For joins, you must use hash partition only. When you go to lookup, then we apply entire partition.
Yeah.
Okay. So here see entire partition is nothing but entire data will be put into every node. So I have a
Yeah.
4 colors of and I have 2 pipes. 4 colors will be replicated into both the pipes.
Okay. Yeah.
Okay. So now you see correct data. So now do you understand the concept of what is pipeline parallelism and partitioning parallelism? Types of partitioning parallelism I will explain on the fly while I'm teaching the stages. But do you understand the concept of what is pipeline and partitioning parallelism? Everyone? Pawan?
Yes.
Rakesh?
Yes, sir.
Yes.
Okay, just remember the pipes and balls. That would be easy. Okay, and frame your sentences. So yeah, this would be one of the basic interview question. What are the types of parallelism? What is parallelism basically? If extraction, transformation, and loading is happening parallelly, that is a parallelism. What is pipeline parallelism? Data stage has a two types, pipeline and partitioning. Pipeline is nothing but if you are using more than one node, data will be distributed across the nodes. That is a nothing but through pipes, pipeline parallelism. What is partitioning parallelism? Partitioning is nothing but partitioning, separating the data. So we are telling data stage, separate the data based on this and this. Okay. So inside partitioning, we have a key based and non-key based partitions. Okay. So hash, whatever we learn here, hash is a key based partition. Okay. These are the things you need to explain when you get what is parallelism. If we just say you have a two types of parallelism, okay, they will ask what are the types of partitioning parallelism. Okay. So instead of they ask, you just give a complete straightforward answer. Okay, that would be easy. Yeah, so that is one thing. So this is about join. How to apply join and how to capture unmatched data by using join and filter. Okay, good. Okay. So now let's take the another job. P D join, right? File new, taking another job. Okay. Let me add the parameter set which I created earlier. So here you see after along with join we have a two other stages for joining. So merge. Okay, I will go for merge. Okay, so I just copied the stages from previous job. You don't copy like that, just try to practice it. Okay, so here all the properties will be saved as a previous job because I just copied the stages from previous job. You can copy it also, but yeah, don't do that. You just but because you are learning, so you just try to give all the properties. So here, why we have to come for merge? So merge stage is used to capture the unmatched data from child link. So here my right table or child link. So here my child link is a department link. So how do I tell that? If you go to link ordering, so what is master table? The department is master table. Okay, let's change it. Okay. So employee, this is my master data. This is not master is nothing but left table. Generally, this is a right table. So that means department is a update link here in the merge language. So employee table is a master data. Department is a update or child link. So merge stage is used to capture the unmatched data from child link only. So it can be n number of child links. Okay. So for example, okay, let's do with one table first. I will try another table. Okay. So merge is used to capture the unmatched data from this child link. Okay. So what is the key column? Based on key column, it will do the join first. Okay. So here we have only one common key column, department number. So make sure you apply hash partition. Here also merge also hash partition. So you have to give the hash partition based on key column which you are joining. Okay, this is also one kind of prerequisite for merge also. Okay, so what are the options? Let's see. So unmatched master mode. Okay, so when child data, so this is a select star from EM. Okay, so see here. So EM2 department. Select star from the PT. Okay, So there is a unmatched master data. Okay, so let's assume here this data is matching with my child table. Let's assume I have a department employee number with the department number 50. Just assume it. Okay, instead of 10, let's assume this is a 50. So when I'm doing a join with the department table, it is a unmatching, right? When it is unmatching, what do you want to do? Do you want me to keep this record or drop this record? Okay, when you say keep means it will be keeping all the records from left table. That's it, right? Master data is unmatching with my child data. Nothing but left data is unmatching with the right data. When it is unmatching, what do you want to do? You want to keep or drop? If I keep it, that is a left outer join. That's it, right? If I keep all the records, then it will be a left outer join. If I drop this record, then it is a inner join. That means only matched records. You understand what I am talking about? Yes or no?
Yeah.
Okay. So here, so that's what the option here. When there is a unmatched records from child table, what do you want me to do? Keep or drop? If you select a keep, it will work as a left outer join. If you select a drop, it will work as an inner join. That's it. Merge supports only two types of join. One is inner join and one is left outer join. But they will ask you when interviewer says like so. It's one of the important interview question. Why? What is the differences between join, merge, and lookup? Okay, join doesn't support reject link directly. Okay, but merge. Why we go for merge? To capture the unmatched records from child data. Okay. So this is just a warning, sworn and rejects when there are a when there are a reject records, it will just warn in the job log. So it's the default options, nothing to do with this. Okay. So I'm going to do inner join, give another link. That would be a reject link. Automatically reject link will be created. Insert job parameter, out path slash merge underscore reject dot ds. Okay. This is a merge, right? Merge mrg. Shortcuts I'm giving mrg, emp, dep to job. Okay. So here you need to pass the columns and then I need to give output file name also. That's it. That's the simple job design. So basically capture unmatched data from one table only, just from the child table. Why we have to go to merge? Because join doesn't support any reject links, then we come to merge stage. So you see one record is unmatched. So what is the unmatched record from child table? 40. 40 is an unmatched record from child table with master table. So that 40 is rejected into rejected data. So all matched records are going to our master data. So here duplicate records are getting dropped. That's why you see 3 here. Okay, 3 records only instead of 14. So 40 is unmatched record from child table. So here what is happening is all the duplicate records are getting removed. Okay. So here what you need to do is you have to take the link other way around. Okay. If I take the links other way around, let me change the link ordering. So I am making department as a master table, employee as a update table. So now how many rejects will come to my reject link? If I take this as a main table, this as a update table. So how many reject records will come to reject link?
Don't get any reject records.
How many? How many are they?
No, you don't get any rejects, right?
Right, we will not get any rejects because
Because
master
all
table,
10:30,
all the,
30 are in the child, the master table.
yeah, but there is an unmatched record. Merge stage doesn't deal with unmatched records from main table. Okay. So after I change the link ordering, make sure you have to remap the key column. Otherwise, it would complain about that. Whether it's a join or merge, if you are changing a type of join, you have to remap the key column. While you are compiling, it will tell you, okay, derivation for this column is not set.
So
And the
Venkat,
numbers.
merge state does not support duplicates.
It will support. Now you see there are duplicates.
Yeah, just because you like reverse department and employee, right? So how come it's if it is employee and department, why it's dropping duplicates then?
Okay, so when it is a repeating records from when it is repeating the records from main table, it's not allowing. But when it repeats the records from child table, it will take it. It will consider it. Okay, that's the limitation it has. Okay, so merge stage supports n input links like a join. Join supports n number of inputs. You can join multiple tables and files together combo. Okay, there is no limitation. So merge supports n input links and n minus 1 output links. So if I keep like this, now I am taking 3 input tables. That means merge supports two reject data, because merge supports unmatched data from child table. So if I take 3 output link, this is a master table. Okay, keep this on a side. Okay, child tables. There are 2 child tables. So from this table unmatched data into this table, from this table unmatched data into this file. Merge supports n minus 1 reject links. If you take another input file, if you take another input table while you are joining, it supports 3 reject links. Okay. If you have a 4 links, 4 minus 1, 3. It supports 3 reject links. Okay. For example, we can create one dummy file. Okay, let's create one dummy file and let's try to join file and table together. Go to ds import, create one new file, dpt contact. Okay, dpt number. What is the column name here? dpt num. Okay, take the same column name, otherwise there's a problem. dpt number and then contact. Department number 10, phone number is 1234556. For department number 20, 4566789. For 30, 98764. For 40, some random number. Okay. So this is a EPT contact. Okay. Now let's try to join it. Instead of this, I will join with the file. So how do you read a file? You need to import the metadata for file. So here I am not importing it. I'll just directly I will give here the EPT number and okay, it's a varchar. You don't need to select Unicode. Okay, contact number length 14. Yeah, you can keep it, no issue. Okay, there are only two columns in my file: department number and contact. First one is integer. Second one is also integer. You can select integer. No issue. Okay, length if you don't know, just ignore, remove it. If you know it, just keep it. Okay, maybe you can take 10. Okay, that is fine. So format, what is the file format? What is the delimiter of this file? Pipe symbol. There are any quotes? No, there are no quotes. Okay, so let's add another department also. Okay, and then null field value. Make sure you handle the nulls and the file. Okay, insert the job parameter path slash. What is the file name? dep_contact.txt is the file name. First line is column name true. That's how you read a file. Make sure we have to import, but instead of importing, I used it manually. So I will keep my employee as a main table. Link ordering. I will keep employee as a main table. The EPT as a child table 1, update 1, and then the EPT 1 as a child table 2. Okay, so now I will give it 2 reject links. Okay. We go to output, we have to remap basically, because here new columns are added, contact also added. So here you see it is complaining merge is supporting n-1 reject links. If you want, you can take 2 reject links, otherwise don't take anything. That's what it says. Okay. So here I will give merge 1.ds. Okay. So how many records will come to this table from this file? Look at the data. You should be able to tell. Then only you understand the concept. So how many records will go to second reject file? So this is a base data. I'm joining employee table data with this department contact table. Okay, so what are the unmatched records from child table?
And 50, right?
Sorry, how many?
Department number 2, right? 40 and 50.
40 and 50 are the unmatched records from main table, right?
Yeah.
From the child table. Okay, that's it. Only these two will go to second reject link. That's what you should understand. Okay, designing job, not designing jobs. Okay, designing jobs, it's easy. So concept with designing job. That's what the analytical thinking. We are data engineers. So if you are good in this kind of concepts, you can even learn reporting also. Tableau, Power BI. That is also, that needs more analytical thinking than this reporting. Otherwise, you can't create a reports, dashboards and all. See here, 2 records. I mean, in real time, you cannot predict how many records, but with the sample data, you should be able to predict. If you don't understand this, you can't understand the huge data. It is just capturing unmatched records from child tables. That's it. Table or file, whatever it is. See, 40 and 50. That's it. Okay. So while you are practicing, you create your own data. So you create a tables. You create a 2 tables. One with your names, another file with maybe department like AEC, CSC, IT. Okay. Another file with your contact numbers, like that. So just try to practice same as it is first, and then after that you change your sources and data with the files instead of taking tables. Okay, so here I forgot to apply hash partition, I guess. Yeah, if you apply, you'll get best speed. I did apply, okay, but it's not redistributed the data because it's already in sorted order, particular sorted order, so it is not redistributed. You see here. So here is a red color symbol, that means it's a redistributed symbol. Okay. So yeah, that is about merge. Okay. So why we go to merge? To capture the unmatched data from child links or update links individually. So you cannot do this in a join stage. So that's why we go to merge. So what is the difference between join and merge? You have to tell. Join supports 4 types of joins: inner, left, right, and full outer joins. Okay, so it doesn't support any reject links. Okay, when you have a large amount of data or huge amount of data, then we use a join stage. So but when you come to merge, because join doesn't support reject links, so merge supports only 2 types of joins. When unmatched master mode equal to keep means it's a left outer join. You can't just tell keep and drop. You have to tell the option name also. When unmatched master mode equal to keep, then it is a left outer join. When you take a drop, it's an inner join. And merge supports n-1 reject links. Okay, if you have 3 input links, it supports 2 reject links separately. It will give output. Prerequisite for these two is make sure you apply hash partition based on a key column you are joining, and then sort the data. Then stage would work. You will get a best speed. That's nothing but a performance tuning technique. If you don't apply it, then you will lose the speed. Okay, so that's what you should tell when they ask in interview. Okay, so are you guys good with join and merge, and how to apply hash partition? At least you understand the concepts, right? You cannot visually see how the data is flowing on the backend, but that's what the meaning. Okay. I think that should be good. Okay. So yeah, I will share the recording once it is available in cloud. I think you guys, yeah, unless you have any doubts, you are free to go. I'll give you 8 minutes back. Anything, Shweta?
Yeah, I wanted to ask about the join. You said it supports any number of input links, right?
Right. Yeah. Join supports n number of input links.
So how will we know which one is the left table, which one is the right table?
Link ordering. When you open a link ordering,
So it will the topmost table will be the left, and each of the
no, not like that. So I can even put this on the top. Okay, so go to link ordering. In the link ordering, left is a link underscore emp. Which one is link underscore emp? This one is my left table.
Yeah, no, like if there is, like, let's say one more Oracle connector, then which, if there are 3 there, then which one is the left?
Okay. Which one you see here left?
Oh, okay.
Okay, so that's what the link ordering I've been telling. Link
Oh, okay.
ordering will tell you which one is left. Okay, if
Okay.
you give another one also, it doesn't matter.
Oh, okay.
That's why I told you to rename the links to identify easily. Okay, you
Yeah.
see, left one is this and right is this intermediate. Okay,
Okay. Yeah.
there
Got
is
it.
no limitation. Okay, join supports an input and one output. That's it. Merge
Okay.
supports an input, one output, and n minus one rejects. Okay.
Okay. Okay. Thank you.
Okay, guys. Yeah. Good. Then, yeah, we'll meet same time tomorrow. Okay. You can drop off.
Yeah, and regarding the interview questions, can you please send it?
Yeah, I need to share. Aarti, do you still have them, Aarti? The interview questions I shared?
I have few. Yeah, one you send me. I have Venkat. But where should
Whatever I have
where should
sent in WhatsApp.
where should I send them?